So in this problem, we have an inclined plane with angle beta, and with have a projectile with the angle alpha, and I want to find the distance which the projectile will land on the incline. Suppose here, so we want to measure that distance. That was the motion. Okay, so in part A, first let's consider the motion of the projectile alone. The x-axis will be the velocity, which is v0 cosine alpha, times the time. In the y-axis we have acceleration, so it will be v0 sine alpha t minus 1/2 gt squared. So we need to make one equation in terms of position only. We don't need the time, because I'm going next to consider the incline. So I need to use the equation which represent any point on the incline. So let's solve for t from that equation. So t is equal to x over v0 cosine alpha, and substitute it here. v0 sine alpha x over v0 cosine alpha minus 1/2 g x over v0 cosine alpha squared. So I can get rid of that. We left with x tan alpha minus 1/2 g x square over v0 square cosine square alpha. This equation is only for the position. So far, I did not consider any inclined plane. This is only the projectile motion. Now, any point on the incline satisfy that equation. X equal d cosine beta, y equal d sine beta. Considering that, okay, so here the x and here the y. So I can plug it here. D sine beta equal d cosine beta tan alpha minus 1/2 g d square cosine square beta over v0 square cosine square alpha. Now we have that equation. We need to solve for d. Let's take everything here to the other side. Now we have the trivial solution, which is d equals 0, because we already know that at the beginning the ball was on the incline. So it is a trivial solution. I can ignore it and divide by d and solve for it. Taking these to the other side, 1/2, I can just do it one time, so 2d. We can take one of these cosine and distribute it here to make that expression better. Let's see how this will be useful. So d equal to 2v0 square cosine alpha over g cosine square beta cosine beta sine alpha. This time will be sine alpha because it will be multiplied by that cosine, minus sine beta cosine alpha. This is the difference identity, so it's equal to sine alpha minus beta. So the final form we have